All right, welcome back. In this video, we are going to be talking about matched pairs T procedures. All right, so this is section 10.4 on the textbook. All right, so in previous examples and the previous videos, we compared means of two populations by using independent sample. Right, so if you think of the number of close friends example that we looked at, the population means that we were comparing came from independent samples. Now, what we are going to do in this section is we are going to compare such means by using a paired sample, or what we call a matched sample. So what is a matched sample? Remember, in a matched sample, each sample is going to consist of one member from one population and a matched or corresponding member in another population. So in each sample, you're going to have one coming from one population and a matched one or a corresponding member in another population. And the example we're going to be using is husband and wife. Right? So if you think about a couple, for each husband there's going to be a corresponding wife, so there's going to be a matched pair. And in the question we're going to be interested in is investigating whether husbands tend to be older than their wives. Right? So that's the question we want to answer. So that is going to be the example we're going to be looking at this entire video. It's example 3.1. All right, what I want you to do at this moment is pause this video and take a couple of minutes to read through example 3.1, read through the question, look at the table, look at the data that's given to you on this page here, and then we're going to start answering questions on the next page. All right, so take a minute, pause this video, and work through the first page here. All right. So as we said, the question we're interested in answering is whether husbands tend to be older than their wives. And to do that, the student went ahead and he gathered ages of a sample of 24 couples taken from marriage licenses filed in Cumberland County, Pennsylvania in between June and July of '93. Right? And for later on, this data is available in StatCrunch in our course group under file name husband-wife. So here we have 24 couples, husband and wife age. So these are our matched pairs here. So in the picture and the table below, what we've done is we've taken all the husband's age, plotted them on a dot plot, and similarly all the wife's age. All right, so there's no pairs here. We've just taken the husband's age, wife's age, and also we have computed the sample mean, sample standard deviation, and sample size for the husband's age and the wife's age here with the help of StatCrunch. Oops. All right. So now what we're going to do is we're going to use this data here to introduce the notion of a matched pair T procedure. But before we do that, we are going to answer a few questions. The first one is that, well, we have two means here, and we know already the non-pole t-test, right? So the question is, we might want to consider using this non-pole t-test to determine whether these sample data provide evidence that the population mean age of husbands exceed that of wives. Why is that not appropriate? Which assumption of the non-pole test is violated? Well, if we just do the non-pole t-test, remember, one of the conditions that need to satisfy was that the samples needed to be independent. Are the samples independent in this case here? No, they're far from it, right? The samples are matched in this case here, not independent. Or matched. Not independent. So that's why we cannot proceed with the non-pole t-test, because we can't just take one random sample from the husbands, a random sample of wives, and compare them, because each of those we're trying to find whether the age of husband exceeds that of a wife for a particular couple, not ages of all husbands versus ages of all wives. So there the samples are matched or paired and not independent. That's why we cannot use the non-pole t-test. That's the assumption that is violated. But let's say before we even answered that question, we went ahead and we did the analysis and we found that the one-sided p-value, so the p-value for our alternative hypotheses that husband's age exceeds that of wives, was the t-statistic was 0.46, and the p-value was larger than 0.3. Also, we found the 95% confidence interval was negative 6.31 to 10.06. So the question is, with this incorrect analysis, what conclusion would we draw? Well, the first one is, let's look at the 95% confidence interval, is that means, well, based on this incorrect analysis, we are 95% confident that the husband's age minus the wife's age is between negative 6.31 and 10.06. All right, so let's look at this interval here. This interval contains 0 positive and negative numbers. So based on this interval here, 0 is a plausible value. All right, so the mean age, the difference in mean age between the husband and the wife based on this analysis could be 0, and that would be a plausible answer. That's the first one. On the other hand, the p-value is greater than 0.3 means that at alpha is equal to 0.10, you conclude or not conclude that the husband's wife is larger than that of wife? Well, the alternative hypothesis in this case here is that the husband's age exceeds that of the wife, and since p is bigger than alpha, we cannot reject h naught, which means we cannot conclude that the husband's age is larger than that of the wives, larger than the wives. All right. So what we did at this point is we wanted to see whether the ages of the couples tended to be related or not. So we took all the couples here and we plotted on a scatter plot the husband and wife's age. All right, so we did a plot here where for each point here, each couple, we plotted a point. On the x-axis, we put the husband's age. On the y-axis, we plotted the wife's age. So for this one here, that means the husband's age is 51 or 52 and the wife's 50. So if we go to that, can we figure out what that is? Well, it looks like that's couple number 3, right? 51 and 50. So that's what we did for all of those couples. We went ahead and plotted those points. So now, based on this question here, I want you to take a second to see if you can answer the following question. Can you comment on whether a respective couple's age are related or not? So, given a husband's age, is there something you can say about the wife's age or not? All right. So, what's happening to the wife's age as the husband's age is increasing? Think about it, we are increasing, right? So it seems like they're related. The plot here indicates that the older men tend to marry older women, and the same for younger men, right? So they seem to marry younger women, so they are indeed related. So they are related. The plot indicates that younger men tend to marry younger women, and same thing for older men. And the same for older couple. All right. So again, the important point here in this particular example is that the samples are paired. So the analysis that we did in B would have been appropriate if the researcher had gone out, gathered samples, one sample of 24 husbands, and then gone out and independently gathered a completely different sample of 24 wives. And that was not the case here. Right? The data here are paired and not independent. So what we need to do is we need a new procedure to analyze the data. And this new procedure are called the paired t-interval procedure. Right? So again, just like in the non-pooled t-test, there's going to be two cases we are going to look at. We're going to look at confidence intervals and we're going to look at hypothesis testing. Right? What I want you to do is I want you to pause this video at this point here, read through that page, and then come back and we're going to work through a few examples here on the next page. All right. So really what I want to do is I want to start by by looking at the remark first. What we are doing here, so the appropriate analysis, since we have a paired data, the appropriate analysis is first, since for each sample, it's a paired sample, so if when you take something from one population, you are going to have a corresponding value in the other population. There's a matched value. You are going to compute the difference of those two quantities there. Then you're going to get one variable, which is the difference, which we're going to denote by D. And then we are going to apply a one mean t procedure on these differences here. All right, so rather than comparing independent samples here, we have matched samples, right? Which means for each husband's age, we have a corresponding wife's age. So what we're going to do is we're just going to compute their difference immediately. And now we are going to look at this difference, which is we're going to look at the mean of the difference. And now we have a one mean, right? So we're just looking at difference. We have this one value, and we're going to apply the one mean t procedure on these differences here. All right, so what that means is if you want to find the confidence interval, well, first find what the differences are, find the mean of the sample difference, find the standard deviation, and then apply that formula there for confidence interval. The same thing for the hypothesis testing, right? So again, it's not as complicated as, all right, it's complicated, but the idea here is since we have a matched sample, we have a matched pair, we're going to compute the difference since we're interested in the difference of means. In this case, we're interested in the difference between husband and wife's age. We're going to compute the difference immediately. Then we're going to do our analysis on the difference. Right? So we're not going to worry about what the husband's age and wife's age were. We're just going to look at the difference in question here. All right. So now what we're going to do is we are going to do that in StatCrunch here. All right, so what we're first going to do is we're going to look at the file. So the file under which this data is saved is called husband and wife, and it's in our StatCrunch here. So we're going to go to StatCrunch, and we're going to go to, again, we're going to go to My Groups. We're going to, oops. All right, so let's just go, when we go to My Groups, there's going to be a husband, wife. Okay, I guess I have to sign in, sorry. Let me just go ahead and do that. Okay. Sorry about this. I guess it logged me out after a time of inactivity. All right, so we're going to go to our groups, which is this group here, and we're going to go to the husband, wife. All right, and here, what we are given is we are given our 24 couples, the husband's age, the wife's age. What we would like to do is we would like to find the difference between the husband and the wife. So we're going to look at husband's age minus wife age. Right? That's what the question's saying. Husband's age minus wife's age, and we're going to create this new variable. And when we have the difference, then we're going to do our analysis on the difference here. Right, so how we're going to compute this is we're going to do compute expression. So this is something we have not done on StatCrunch. If you're comfortable using Excel, this is something a little more easier on Excel than it is on StatCrunch, but the idea is the same. What we would like to do is we'd like to create a new column here where what StatCrunch is going to do is do husband age minus wife age. To do that, we're going to go to data, compute, and we're going to do expression. And the expression we want is going to be husband's age minus the wife age. Oops. Okay, and we're going to call this column husband age minus wife age. All right, and we're going to go ahead and compute this. I don't know why I computed 2, but let's just delete this column here. So that's the husband age and the wife age. So let's just do a sanity check here. So this data here, the husband was 23, wife was 22. The husband's age, whoops, why is this not letting me move? All right, that's the husband's age minus wife age, and that's, all right. So now what the question wants us to do is it wants us to produce a dot plot of these differences and comment on the dot plot in question here. All right, so what we're trying to do at this point here is produce a dot plot first. That's what we're going to do, just create a dot plot. And after we create it, we are going to try to answer the question on if there anything we can say about the difference there. All right, so let's do this graph. We're going to do a dot plot. And the dot plot we're going to do is husband age minus wife age, and we're going to compute it. And we're going to look at that here, and if we look at this data here, as you can see, most of the values seem to be in the positive range here, 0 or bigger, right? So the most of the data is to the right hand side of 0. So this sample seems to indicate that the husband's age is bigger than the wife's age. Again, the question is, just because this sample indicates that doesn't mean the entire population has to be that, right? So this could just be an off sample. What we would like to do is we would like to do a statistical analysis on this question here. All right. So now that we have this here, what we would like to do is we would like to go ahead and compute the sample mean and the sample standard deviation for the difference. All right, and wouldn't it be nice if we already had a column in StatCrunch where we had computed the differences in the husband's and wife's age? Well, we already have that, so we're going to go summary stats by columns, and we're going to ask StatCrunch to give us all the summary stat, but really the two values we're primarily interested in are the sample mean of the difference and the sample standard deviation. So the sample mean is going to be 1.875, and the standard deviation is 4.812. All right, so that's what we're going to go and put ahead. All right, so our sample mean was 1.875, and our sample standard deviation was 4.812. All right, so now what we would like to do is we'd like to determine a 90% confidence interval for the population mean difference between husbands and wives' age, and we're going to interpret the interval. All right, so remember, when we have match sample, we look at the difference, and now we're going to do a one mean t-test on the difference, right? So that's somewhat easier compared to, not somewhat, I think it's significantly easier, right, compared to the non-pool t-test. The first thing is the degree of freedom for a one mean t-test is a lot simpler. What is the degree of freedom? If our sample is 24 and we're doing a one mean t-test, what is our degree of freedom? Well, our degree of freedom is going to be exactly 23. All right. Now we're doing a 90% confidence interval, which means alpha is going to be 0.1, which means we need to find t alpha over 2, which is t of 0.05 at degree of freedom 23. So let's go to our t-table. Let's go to degree of freedom 23. At t at 0.05, we get that our t is 1.714. So let's go ahead and put that in. It's 1.714. Now, we need to know what the sample mean for the difference was. Well, the sample mean for the difference was 1.875. What was the sample standard deviation for the difference, which we're going to denote by SD? It is 4.812, and our n was 24. And if you go back, this is all the information we need to find the confidence interval. So the endpoints of our confidence interval are, and let me just write down the formula once, it is d bar plus or minus d alpha over 2, the standard deviation divided by square root of n. Right, so that's the endpoint for confidence interval for a one mean t-test. Right, so when I plug it in, I get this is 1.875 plus or minus 1.714 times 4.812 divided by square root of 24. So when I plug in plus, I get one of the endpoints. When I plug in minus, I get the other endpoint. So 90% confidence interval in this case here is, if we use our calculator, it is going to be 0.191 3.558. All right, so whenever we look at a confidence interval, what is the question we answer? Whether 0 is not in there or not, and whether the interval is all positive or not. So first, 0 is not in the interval. And secondly, is the interval is all positive. All right. So we are going to get to that. But in this case here, what does the intervals tell us? Well, so we are 90% confident that population mean difference in ages between husband and wife is between 0.191 and 3.558. Right, so that's what it's saying. We're 90% confident that the population mean difference in ages. So the husband is between 0.19 and 3.56 years older than the wife. All right. So remember, the interval does not contain 0 and is entirely positive. Right? So what that means is at 90% confidence, there is a difference in population mean. Ages of husband and wife. All right, so 0 is not in this interval, which means we're 90% confident there's actually there's a difference in population mean ages of husband and wife. And not only that, we're 90% confident that the husband is always older. We're 90% confident that the husband is older than their wives. All right. Remember, how does this compare to our incorrect interval? When we looked at part B, this contained both negative, 0, and positive number. While in the correct one, which is between 0.19 and 3.558, all right, so this one contains only positive ones. So the incorrect interval contains both positive, negative, and 0. Also, which of these intervals is smaller? Let's look at this. Is this incorrect interval smaller or the correct interval smaller? Well, the correct interval is significantly smaller than the incorrect interval. And we're going to get to that in a second, why that is the case. All right, so again, at 90% confidence, there's a difference in population mean ages of husbands and wives, and the correct interval is significantly smaller than the incorrect interval. All right, so next we're going to move on to part H of this example here, which says, using StatCrunch, conduct a paired test of whether the sample data provides strong evidence that the population mean difference exceeds 0. Report all aspects of the test. All right, so again, remember, it's saying whether the data provides strong evidence. It's not giving us a significance level. And really the question in statistics, all right, let me rephrase that. What we'd like to do is we'd like to find the p-value first. And then from the p-value, figure out at what level our data would be significant and at what level it would not be. All right? And we'll make that a little more clear with the help of this example here. But let's now come up with the null hypotheses and the alternative hypotheses. The first one is the null hypotheses, which, since we're trying to show that the population mean difference exceeds 0, our null hypothesis is that the population mean of difference is 0. So the population mean difference in ages between husbands and their wives is 0. That's what that says. And our alternative hypothesis is mu d is positive. Or in other words, population mean difference in ages between husbands and their wives is positive. All right, so now what we're going to do is we are going to compute our test statistic. Our test statistic is going to be our sample mean, which is 1.875 minus 0, which is just 0 in this case here, divided by 4.812 over square root of 24. When I do this, I get 1.91, and my degree of freedom is 23. All right, so we just computed that, but really, the question was saying use StatCrunch, so let's go ahead and use StatCrunch to do this. So let's go to our data here, husband, wife. Let's close this here. We already have the difference, so we're going to do dstats. We're going to do one sample. We have our data, and the sample we're going to be using is the husband's age minus wife's age. Right? Now we're looking at the hypothesis test is mu is equal to 0 as the null hypothesis, and the alternative hypothesis, the one we're trying to see whether the data provides evidence for, is whether the population mean exceeds 0. And as usual, I'm going to ask StatCrunch to give me a p-value plot because I like a nice picture with p-values there. All right, so this is right-tailed, so let's go ahead and compute that. So as we said, degree of freedom is 23. We already computed our t-value is roughly 1.91, and according to StatCrunch, our p-value is 0.0344, and here's the picture here. So let's go and put this here. Our p is 0.03. Sorry, I forgot. 44. Right. So now that we have the p-value, what we would like to do is we would like to test whether the sample data provides strong evidence on whether the population mean exceeds 0. All right, so what we're going to do is we're going to look at the standard significance we look at. So what happens at alpha is equal to 0.05? Do we reject our H0 or do we fail to reject H0? So in this case, we can reject H0, right? What about our next significance level? So let's say alpha is equal to 0.01. What can we do at this here? We can't reject H0. So what this means is the data provides moderate statistical evidence that the population mean difference in ages between husband and their wives is greater than 0. So at 0.05 we were able to reject H0 in favor of HA. So at 0.05 significance level we were able to say that the age of husband exceeds the age of the wife, but at significance level 0.01 we were unable to say that the husbands tended to be older than their wives. So that's what we're going to call a moderate statistical evidence. All right. So we're going to look at I, J, and K here. So one thing I would like to mention here is I'm not going to do as much writing in these ones here. I'm just not going to write as much as possible. I'm going to talk through the ideas. To find the write-up, I have posted a filled out handout for this weekly worksheet on Moodle, so you can read. If you like having notes to read through, you can just print those out or copy those onto your own notes. I'm not going to do as much writing on this particular example here. Oh, one more thing I wanted to point out here. We could have done the exact t-test without actually computing this difference here, even though I want you to think, I wanted to emphasize the point here that when we're doing paired analysis, we are doing it on the difference here. We could have just asked StatCrunch to do the analysis without actually computing the difference, and to do that, we'd go to t-stats, but instead of one sample or two sample, we'd go to paired. So the sample 1 would be husband's age, and sample 2 would be the wife's age. And we're looking at the hypothesis test for the difference, and our alternative hypothesis was bigger than 0. And let's see, if I do the p-value plot and I compute, I see that my p-value, oops, oh my goodness. All right, my p-value again is 0.0344. And we get the same picture. So rather than computing the difference and then doing the one sample t-test on this particular here, we could have directly done the t-stats on paired sample. All right, so just pointing that out before we go back. All right, so now the question is, what we said is that at 5% significance level, we were able to reject H0. And remember, in part B, we said even at 10% significance level, so the p-value was greater than 0.3, we could not reject the null hypotheses. So what is the difference between the correct answer and the incorrect is we are reaching the opposite conclusion as to our incorrect decision in part B. So in part B, we were able to conclude that 0 was a plausible answer. In this case, we're saying at 5% significance level, 0 is not a plausible answer. So we can reject the population mean being equal to 0 and accept an alternate hypothesis that the difference in ages, the population mean for the difference in ages is greater than 0. All right. So again, similar to the case when we're looking at the non-pooled t-test, there were a few assumptions that needed to be satisfied. All right, so let me scroll up to the page where we had the things that needed to be satisfied. So the first one, the thing was we needed simple random paired sample. Well, we have the paired sample part, but do we know if this sample is a simple random sample? Well, the person, there's nothing to say that, right? So if you look at the question itself, The question says he just went to the county and he just picked up the marriage licenses. This is not really a simple random sample. Sorry, I keep scrolling too much. However, you have no reason to doubt that this is not representative of all marriages, right? So there's nothing to say that the researcher has a biased view, at least in Cumberland County where this data was collected. However, second, the sample is not large. Remember, the sample is 24 here. It's not bigger than 30. So we don't know it's a large sample. Neither do we know the difference is normal. So what do we do in this case here? If we don't have a large sample and we don't know the population is normal, that's right, we are going to look at the normal probability plot for the difference and see if it's roughly linear or not. So we're going to go to graph. QQ plot, remember, gives us the probability plot. We're going to look at husband's age and we're going to compute this. And if you look at the data, that's roughly linear here. All right, so if you get rid of that outlier there, we can convince ourselves that that's roughly linear. All right, so finally, we would like to talk about why the paired result produces such a different conclusion than the independent sample analysis. So when we looked at the incorrect analysis, our confidence interval was really large. In this case, our confidence interval is significantly smaller compared to that. And our p-value when we did it, when we treated the samples as independent was really large, but when we did it as a matched pair, it was really small. All right. So the question is, why is it so different? And really, the different conclusion can be attributed to the fact that when we pair these data, that reduces the variability by a significant amount. Think of finding the standard difference in ages, right? There's a lot of older husbands, a lot of younger husbands, a lot of older wives. So if we're computing the standard deviation of difference in ages, when we're looking at the difference between the ages of husbands and wives, rather than the standard deviation of ages, the standard deviation of difference in ages is significantly smaller, right? Significantly, it's much smaller than standard deviation of ages. All right, so what this does is this makes the observed differences, remember, if everything else stays the same, and we make the standard deviation smaller, what happens to the p-value? We looked at this in the case when we had independent samples. The same idea happens here. It makes the observed difference in mean ages seem larger. So something is less likely to happen. So let's say you say, rather than thinking in terms of this idea, we'd like to think of it in terms of formula. If you go to the formula here, if you look at the standard deviation, it's in the denominator. If the standard deviation is smaller, what happens to the test statistic? The test statistic becomes larger. And if the test statistic is larger, you're going to go to more extreme values. So what does that mean about the p-value? You get a smaller p-value. Right? So that's the idea here. When we think in terms of independent sample as opposed to paired analysis, the standard deviation of difference in ages, right? So husbands and wives, you might look at the data. Again, I apologize for scrolling back and forth here, but this data here, if we're looking at the standard deviation for the differences are generally small numbers. So the standard deviation, it's not going to vary that much as opposed to the standard deviation of ages, because you have a husband age 25 here and you have a husband age 71. The same thing for wives, 22 and 73. Standard deviation of ages is a lot bigger than the standard deviation of difference in ages. And that's the reason why we get smaller confidence intervals and smaller p-values when we're doing paired analysis as opposed to when we're doing the independent sample or the non-pooled T sample analysis. All right, so that's where I'm going to stop here. Please work through the example worksheets. There's a few examples. I will post a written solution to those examples. But remember, you are supposed to turn in the example worksheet before you get to look at the solution. So if you have any questions, please feel free to stop by office hours or talk to members in your group, and I'll talk to you soon.